Hello everyone, it's November 28th. Alright, late at night and still having an issue with coughing. And I thought about this yesterday, but so far still haven't got a better idea of how to deal with this. Well, let's see if we have any Ghana today to do that. Alright, but let's do this first. Insert, delete, get random 01. What does that mean? Randomize set. Initialize a randomized set. Inserts a value to the set if not present. Return true if the item was not present. False otherwise. Remove an item val from set if possible. Return true if the item was present. False otherwise. And then get random returns a random element from the current set of elements. Guarantee that at least one element exists when it's called. Must have the same probability, okay? Must implement the function of the class such that each function works in O1 time complexity. Actually, I'm not sure. Is random gets O1? I don't know. But the underlying is going to be a set. If the underlying is a set, then insert and remove will be easy to do. But how do we do get random? We have to get a random value. Well, if we do a get random value, it cannot be a set, right? Because I need to pick a random value out of it. Is this like reservoir? It could very well be the reservoir thing. But I don't remember how to do the reservoir thing. If I don't use that reservoir thing, what would you do? It requires ON, so it could be, just not. I don't know. Get random. But hold on, it just returns a random element. But if we call random on a set, yeah, I don't think that works. If we call random on a set. Index. Index. I don't know. Index? I don't think so. Maybe it is the reservoir. I forgot. What's it called? Random? Reservoir sampling. Let's see. What are we doing? R will contain the result. So 1 to K. Okay, replace elements with gradually decreasing probability. So every new one, get a random integer, generates a uniform integer from A to B. Okay, so that's the j is the index, and then if j is smaller or equal to k, then rj which is the result equal to si. The probability that a new input enters the reservoir is equal to the probability that an existing input in the reservoir is retained. What's I and what's k in this sense? Initialize an array R index from 1 to k containing the first k element of the input. This is a reservoir. For each new input, generate a random number. Okay. If j is in the first k items, set rj equals to the new x. Basically, we say we want to get sample k. Result of the k. So in our case, we can say k is just, yeah, I think we can use this. But if we don't use this, I feel like, I mean, we can just just get random. I think I can get random from a set. I'm actually not sure. Let's do choice. Probably not. Ooh, you can't. In this case, then it's not 01. Okay, so we cannot do it that way. So in our case, we only need to take one random, right? So each new value comes in, we want to take one random. So we just need to fill the first one, right? And then every single time it comes, I will do this and decide whether we want to change it. Okay? That seems to work. I want to go through the proof again. Yes, the first is right. So every time a new one comes in, process is k divided by I is included in the before is yes, it's true, because we want to pick k out of the I, right? So the probability of input is this. Input is included with probability by definition for any other, okay? The input is included just before is this. If it is still included after it's processed, it's going to be this on 1 minus, because it's included before and it's not excluded. It's excluded is going to be 1 over I plus 1. One of them, right? So, yeah. The probability that it will be replaced is going to be the new generator is one of them, and it's going to be the kth. Okay, I think it makes sense. Okay, makes sense. We can try this. I'm going to use a reservoir sampling. Self dot random set. Okay. Insert return true if item was not present. Okay, and we just say if val not in self dot random set, and then self dot random set, add the val, and then we'll return true, otherwise return false. Remove. And true if it's present, false otherwise. In self dot random set. Okay. Then self dot remove val. I'm gonna return false. Okay. Now this is gonna be interesting. So we should say self dot r equals to what is this equals to? Actually, it doesn't really matter what it's equal to. You know what? It might actually be easier just to do it this way. But you have to set up a value. What value should we set? That's fine. Okay, and we say get random Actually, no. Get random shall just get this value. Yeah, we shall handle it. We shall handle it when we insert. Every time we insert, we should change the self.r. And every time we remove, what are we gonna do if we remove? Yeah, what are we gonna do if we remove the random value? How are we gonna change? Yeah, we have the current random value. If we want to remove this current random value, then it's as if we need to recompute, right? Recompute. Oh gosh. Yeah, every time I insert, we can run this. We get a random. Now we say if it's larger than, and then I replace this, right? And then insert is easy. Yeah, the problem is how do we do remove? How do we handle remove? If I remove a value, if it's not a random value, then I think it's fine. Or maybe it's not. Remove. Once we remove, once we remove this value, hold on, let me think. Alright, we get a random value, and then if it's smaller or equal to, in my case, k is going to be 1. Right? Now, in my case, k is going to be a 0. Right? If k is equal to 0, then we're going to swap. Yeah, that's the index. But what if I remove? Each time the new thing comes on, I have the index. Okay, I have the index. So so if I need to remove something, Yeah, add was easy. Basically, you add something. I get a random from 0 to the current I, right? 0 is the current index, and then we say if it's smaller or equal to 0. Basically, just when it's equal to 0, replace it. And then you can say that is a random value. But if you remove this, okay, if you remove this, and then you call for random again, then what do we do? So when you remove, what you're going to do if you remove this random value? If I remove a value, I mean, I can just use, let's say, a dictionary or something like that to deal with, but that's not all one. Yeah, what troubles me is the remove. I don't have a value like for remove. Huh, I have no clue. What I can do, I can just say, let me see if I can use past. Yeah, this is not really following the requirement, but kind of don't want to do. So I'll just try it first. See if it works. See, it does pass, right? But that's definitely not what we want. Gotta be a way. This is cheating. We use on for the get random method, not the required one. Alright, so how can we use reservoir to handle deletion? What does it mean by deletion? So we have a bunch of values, okay? And then, well, also remember they're unique. So we say we randomly delete one. Not randomly delete one. We pick a random value, right? Out of all of them, we pick a random value. And then I can use reservoir sampling. Like every time we add a new one, we can decide what this random value is going to be. So we add a new one, right? We add a new one, and then we decide. We add a new one, Then we decide. And then we need to remove. Okay, let's say I remove this one. And if it's the removed one is not, well, the probability that things gets removed, well, we don't know what the probability of what things gonna get removed. But we can say when a value gets removed, when the value is not removed, right? Then can I just keep it? Or do I have to recompute? I mean, if I know the previous insert value, right? If I insert, and then I remove. If I know the previous, and then we remove that value, then I can pretend to insert again, right? I can pretend to insert again on the probability side. And that will be a smaller, right? Oh man. Or we use a list. Okay, we use a list, and we have all the set. So if it's a new, we just put at the end. If we want to remove, we will what do we do if we remove? Well, it could be a dictionary. Okay, if remove, we go there and then put the value at -1, and I don't know, it might work. But it'll take a lot of space. Yeah, I can say index map dictionary vowels. It's gonna be this. Okay. Index *0. Okay, I can say self.indexMap how equals self.index. Remove. Yeah, you remove. Does the index go? No, index doesn't change. Index always go big, right? So when you remove, say if this is in index map, self dot index map val equals -1. Okay, that's removed. And then for this one, we're just gonna say val true. Okay, so res equals to choice self dot vals. Oh, right. I mean, maybe we could use the keys. Let's just try this. Then we say if self.indexMap res is larger or equal to 0, turn res. Otherwise, try it again. Does this one count? So get random is faster than on, but probably not sure if it can be counted as O1. Try this. Huh. It actually doesn't work. It actually doesn't work. Well, it's actually a different problem. It's not a random problem. Actually, it's gonna come in here. Oh, I see. If it's not or now is smaller than 0, because I turn it to -1. Nah, then it shouldn't. Oh. Okay. Okay. A val not in, then we do this, and this. Okay. We say if So it's inside, it's in, okay? Then we do these two things as well. Then you don't need index. And what do you use index for, right? Yeah, exactly what you use index for. You can just say, if it's not in M, then this shall equal to 1. Doesn't really matter what it equals to. If it's smaller than 0, right? If it's smaller than 0, I actually just set it to 0. If it's equal to 0, then we just do this. Then return true. Like that. Set to 0. Oh, it could also be, it's already set to 0. Or, no, if it's in and if it's equal to 1, right? Which means it exists, then I can remove it. If it does not exist, it could be either not in M or it's a 0. Then we just don't do anything. Okay. Try this one. Huh. Hey, what's the problem here? Oh, I haven't changed this. If it's equal to 1, that was a mistake. Yeah. Okay. Pretty sure it's not what we want, but that's what we get. I mean, now that we are handling the problem using a dictionary, maybe we can, because I can always call keys, right? So maybe we can do this again. I don't know. Okay. Insert. Okay. Remove. Just remove it. Random choice. Like this. Not sure if it counts. Probably cannot got choice on this. How about I do keys? This will help. Oh, you cannot do it this way. Okay, no, it's fine. All right, then I don't know. What's the smart way to do it? Let's check this. It must be the reservoir, but I don't know how to handle the reservoir. Oh, it's a swap last element. Now that you mention it, I kind of remember the swap last element thing. Holy crap. So what we're saying is we'll keep index and the values, okay? And then we random pick one. And after we random pick one, we'll always swap it to the end. Wait, hold on. Random pick one. Yeah, remember this. We always put the value to the end. So when we remove it, it would just pop. Right? We just pop. How do we do that? I mean, the remove. No. It's the remove. We put it to the. Oh, it's the remove. We put it at the end. This is the official. This is the smart solution. Use pop of a stack to remove, and use a value index use stack to keep track of all unique values. Use a value index map to keep track of the indices, right? Indices of all values. Once a value, if a value is removed, right? If a value is to be removed, we find its index first, and then swap it with the top of the stack. Then we pop the stack for removal. That's the trick. So I can say I also have M as a map, and then stack. Okay. So we can say if it's not in, we need index as well. Index. I don't need index. I don't need. Self.stack dot append, right? Val self.m val equals len self.stack -1. Okay, and this is dot stack. Very easy. Removal, that's the one. If it's in M, all right, of course we won't delete it, but we want to know the index. This one works. I'm gonna pop this value, we get the index, right? And then we say self.stack index self.stack -1, which is the top. From index go to -1, and then from -1 go to index. right? And then pop the stack, then return. Yeah, something like that. Interesting. Output is 1. Yeah, well, a lot of things is not right. Hold on. I insert 0. That's true. Why would I get 1 out? Oh. Once we swap, then the index has changed. Then we should say self.m self.stack index, because I swapped the last one, right, to the index position. So this shall equal to index. Still not right. Now we have issue with the first one. Let's see. Insert 0, remove. Yeah, insert 0, and then remove insert 0. Get random is 0. Remove, and then insert. Wait, hold on. Output is false. Yeah, because I removed it. Isn't this already get 0 out? And I put 0 back in. Ooh, that's the problem. Hold on, let me think again. If these two values are the same, right? If the two values are not the same, because they're unique. So when they're the same, that just means the value gets popped and the last value. So what we should do is now to put it back. So we should not put it back if they're the same. Or we're gonna say if index is not equal to len -1. Now we do this. There we go. There we go. That's the solution. Oh, man. I'm not feeling well. Yeah. I do this first, and then I delete it, and then I swap them. I see. It's the same. All right. I'm gonna call it. Oh man. I'll see you guys tomorrow. Adios.